Hi to everyone, myself Dr. Dhananjay Rao, working as assistant professor in the Department of Chemistry. Today I am going to teach external treatment of water and desalination of water. Today I am going to teach external treatment of water and desalination of water. See, before going to this, we should know about brackish water and desalination. What is brackish water and what is the desalination? See, the water containing dissolved salts with peculiarly salty taste is called brackish water. Brackish water nothing but the salts present in the water, means the water contain salts. Okay, that water is called brackish water. Peculiarly it contains salty in taste. Okay, that water is called brackish water, or we can call as saline water. The process of removing common salt or NaCl or sodium chloride from the seawater is known as desalination. What is desalination? The desalination is a process of removing common salt or sodium chloride from the seawater. It is called desalination process. The common methods used for desalination are electrodialysis and reverse osmosis. These are the two methods we can use for the desalination process. Means we can remove by using this desalination process, we can remove the salts like sodium chloride, magnesium chloride from the seawater. This process is called desalination. What are those processes? Electrodialysis and reverse osmosis. By using these two methods, we can remove the salts from the seawater. Those processes called desalination process. Reverse osmosis or desalination. Now we are going to learn about reverse osmosis or desalination. What is osmosis? Osmosis is nothing but the spontaneous flow of water from low concentrated to more concentration side through the semi-permeable membrane. What is osmosis? The spontaneous flow of water from low concentration to high concentration side through the semi-permeable membrane. Okay. In the osmosis process, the solvent molecules moves from low concentrated to high concentration side. That process is called osmosis. Semi-permeable membrane is one which permits only water or solvent molecules to pass through it. Semi-permeable membrane only allows the solvent molecules, not solid molecules. Semi-permeable membrane allows only solvent molecules like water or solvent molecules to pass through it. It stops the solid particles present in the solution. Only it allows the solvent particles. Okay, through the semi-permeable membrane, it allows the only solvent particles. Cellulose acetate, polyamide, egg membrane, goat's bladder can act as semi-permeable membrane. These are the examples for semi-permeable membranes like cellulose acetate, polyamide, egg membrane and goat's bladder. These acts as semi-permeable membrane. These allow the only solvent particles, not allow the solid particles. See, the pressure required to stop the spontaneous osmosis process is called osmotic pressure. What is osmotic pressure? Osmotic pressure nothing but the pressure required to stop the spontaneous osmosis process. The pressure required to stop the spontaneous osmosis process. The pressure is called osmotic pressure. What is osmotic pressure? Osmotic pressure nothing but it is the pressure to stop the osmotic process is called osmotic pressure. See, this is U-shaped glass tube. In this low concentrated side, this is its solvent content low concentration. Here high concentrated solution. This is low concentrated solution left side, right side high concentrated solution. These two solutions are separated by semi-permeable membrane. These two solutions are separated by semi-permeable membrane. See, this is low concentration side, this is high concentration side. What is osmosis process? Osmosis process nothing but the flow of solvent molecules from low concentration to high concentration through semi-permeable membrane. That process is called osmosis. So these two are separated by semi-permeable membrane. So here it contains low concentration, it contains high concentration. So due to osmosis process, here from low concentration, the solvent molecules moves towards the high concentration side. This process is called osmosis process. The pressure required to, what is osmotic pressure? The osmotic pressure, the pressure required to stop the spontaneous osmosis process is called osmotic pressure. Okay, the pressure required to stop the osmosis process is called osmotic pressure. So if you apply the pressure on high concentration side to stop the flow of these solvent molecules from low concentrated to high concentrated, means to stop the osmotic process, that pressure is called osmotic pressure. To stop the osmosis process, we have to apply some pressure towards high concentration side. That pressure is called osmotic pressure. If you apply the osmotic pressure, the flow of this solvent molecules from low concentrated to high concentrated will be stopped. Okay, na? That pressure is called osmotic pressure. Okay. If pressure is applied more than osmotic pressure on concentration side, the osmosis will be reversed. If osmotic pressure, that much amount of pressure if you apply, the only it stop the osmosis process. If you apply more than osmotic pressure, if you applied pressure is more than osmotic pressure, what happens? See, the flow of osmosis reverse, means the flow of solvent molecules flows from high concentrated to low concentrated through semi-permeable membrane. If you apply the pressure more than the osmotic pressure, if you apply pressure more than the osmotic pressure towards high concentration side, means this side if you apply more than osmotic pressure, okay, if you apply pressure more than osmotic pressure, then what happens? The flow of these solvent molecules, from high concentrated side to low concentration side, okay, high concentrated side to low concentrated side, okay, through semi-permeable membrane. The osmosis process is reverse. That process is called reverse osmosis process. When will reverse osmosis process occur? If you apply the pressure more than that of osmotic pressure towards high concentrated solution side. Okay, that process is called reverse osmosis process. Okay, see, this is the reverse osmosis process. By using reverse osmosis process, we can remove the salts from the seawater. Okay, we can remove the salts from the seawater by using reverse osmosis process. See the application of reverse osmosis process. See, in the reverse osmosis, the pure water is separated from the contaminated salt water. In the reverse osmosis process, by using reverse osmosis process, we can pure the water. Okay, is separated from the contaminated salt water. We can separate the pure water from contaminated salt water by using reverse osmosis process. See, this is the setup for reverse osmosis process. This is the one box type of container. Okay, this is the box type of container. In this, two rooms are there. One above room, one is below room. Okay, these two rooms are separated by semi-permeable membrane. These two rooms are separated by semi-permeable membrane. On upper side, we have to take seawater. Seawater nothing but it contains lot of salt. So these are concentrated. This is the concentrated like solution. Okay, seawater acts as high concentrated solution. Okay, the bottom room. Okay, this room contains fresh water. Means in this there is no salts. Okay, in upper side means above room it contains seawater. The seawater nothing but it contains lot of number of salts. Okay, so it is acts as high concentrated solution. Okay, in bottom room you have to take fresh water, means it does not contain any salts, so it acts as low concentrated solution. These two solutions are separated by semi-permeable membrane. These two solutions means high concentrated solution seawater and low concentrated solution fresh water. These two types of waters are separated by semi-permeable membrane. Okay, these two rooms are separated by semi-permeable membrane. See, this is seawater, means high concentrated solution. This is fresh water, means low concentrated solution. In upper side, this is a piston. The black one is piston. Okay, black one is acts as piston. If you apply pressure more than that of P naught nothing but osmotic pressure. If you apply pressure more than that of osmotic pressure, what happens? Reverse osmosis takes place. If you apply pressure more than that of osmotic pressure, then what happens? Reverse osmosis takes place. So here what happens? Reverse osmosis process occurs. What is reverse osmosis process? The flow of solvent molecules from high concentrated to low concentrated. Okay, here what is the high concentrated solution? High concentrated solution is seawater. Okay, here high concentrated solution is seawater. What is the low concentrated solution? Low concentrated solution is fresh water. So if apply pressure more than that of osmotic pressure, what happens? The reverse osmosis takes place, means the flow of solvent molecules from seawater to this fresh water. Only the from seawater to fresh water, what happens? Solvent molecules flow. Okay, remaining molecules, what are left here? Solute molecules means salt molecules only present here. Only solvent molecules flows through the semi-permeable membrane. Semi-permeable membrane allows the only solvent molecules. Does not allow the salt or solute molecules. So here only semi-permeable, through semi-permeable membrane, the solvent molecules means just pure water flow through this semi-permeable membrane and enters into the fresh water. So here what happens? In fresh water volume will be increased. Here the seawater volume will be decreased. Okay. In this reverse osmosis process, what happens? The solvent molecules flows from high concentrated to the low concentration side through the semi-permeable membrane. From this outlet we can collect the fresh water. Okay. Here the volume of fresh water increases, the volume of seawater decreases. By using this reverse osmosis process, we can purify the seawater. From seawater we can remove the sodium salt or magnesium salts. Means salts present in the seawater we can remove by reverse osmosis process. This type of membrane filtration is called superfiltration of hyperfiltration. This type of reverse osmosis process we can also call as superfiltration or hyperfiltration process. See, advantages of reverse osmosis process. What are the advantages of reverse osmosis process? See, this method has greater advantages of removing ionic, non-ionic, colloidal and high molecular weight of organic matters. By using reverse osmosis process, we can remove the ionic, non-ionic, colloidal and high molecular weight organic matters. Okay. The lifetime of membrane is quite high. That means 2 years. Up to 2 years, the lifetime of semi-permeable membrane is quite high. That can helpful for up to 2 years. Okay. The membrane can be replaced within few minutes. For the replacement of the semi-permeable membrane takes very few time. Okay, few minutes. Okay, the membrane can be replaced within few minutes. The semi-permeable membrane can be replaced within few minutes. It provides nearly uninterrupted water supply. It completing the replacement of semi-permeable membrane takes place few minutes. So it provides nearly uninterrupted water supply. There is no interruption in water supply. Due to low capital cost, low operating cost and high reliability, this method is superior than other methods. Due to low capital cost and low operating cost and high reliability, this method is superior than that of other methods. This method is superior than other purification methods. See, applications of reverse osmosis process. The reverse osmosis plays a major role in providing potable water defined by the WHO criterion of less than 500 ppm of dissolved solids. The reverse osmosis process. By using reverse osmosis process, the outcoming water contains less than 500 ppm TDS. Total dissolved salts present in the reverse osmosis output water is less than 500 ppm. Extremely high quality water required for nuclear power plants. For nuclear power plants to power generation, we need high quality of water. We need high quality of water. Okay, this can be made from as seawater by reverse osmosis. This high quality water which are using in nuclear power plant can be purified by using this reverse osmosis process. These are the applications of reverse osmosis process. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.